In this demo, I'll be showing you iterators. Iterators are a simple way to traverse and manipulate data structures. As we can see here, we have a new vector of numbers. The numbers go from 1 through 5. If we wanted to, for example, create another vector with all of these numbers, but add 1 to each number, here's how we would do it using what we currently know. We would create a mutable vector. I'm just naming mine +1. We then go through each number in the numbers vector here, and we just add 1 to it, and then push it onto our +1 vector. This num +1 will go through each one of these and add 1 since it's within the for loop. Creating a new vector in this way by adding 1 to each number is fine. However, there's a much easier way to do this using iterators. To do this with iterators, I'll create a new variable. I will then take the numbers vector and call .iter upon it. When we call .iter, we create a new iterator. I'm then going to map the values, and the map function, as you know, takes a closure. We put the variable name between pipes, and this will just represent each number within our numbers vector. I'm then going to take num +1 to add 1 to each number, and finally I will call collect. Collect simply creates a new vector out of this iterator. We also need to specify that we are actually creating a vector by using type annotations. The reason we need to use type annotations in this case is because iter and collect operate generically on any kind of data structures. So it can work on hash maps, vectors, and other kinds of data structures. Therefore, we need to tell collect that we're working with a vector, and we can do so with type annotations. There are other ways to do it, but type annotations is one of the simplest ways. Let's walk through this one line at a time so we can see how it works. First, we're creating a variable. We're giving it a type of vector. We're using the underscore, which tells the compiler that we're making some kind of vector, and the compiler will just figure out what kind it is. We then take our numbers vector, which was defined here, and we call the .iter function on it. The iter function creates an iterator. And an iterator is a structure that will traverse through each element of this vector and perform some operation upon it. In this case, we're performing the map operation on the items. And as you know, the map function accepts another function as its argument. In this case, we are giving it a function that takes the number and adds 1 to it. Finally, we call the collect function, which will then convert the values into a vector. The reason we need to do that is because iterators on their own don't actually do anything. You need to collect it into something or perform a for loop on it in order to take action. So you could think of an iterator as a plan. We're telling the program we want to take the numbers vector. We're planning on going through each item in the vector. And when we do go through each item, here's what we want to do. We want to map each item by taking the item, adding 1 to it, and then finally, when we're done, we want to collect it. And again, the collect function will collect the items into a new vector, since that's what we specified in the type annotations. Iterating over data is one of the most common things you'll be doing while programming, so I'm going to go over some of the more frequently used functions that you can call on the iter method. Another function you can use is the filter function. The filter function will filter out items and only keep the ones you want. The filter function is similar to map, where we will need to supply a closure or a function. In this case, I'm going to create a closure, and we'll filter all the numbers that are greater than 3. So if the number is less than or equal to 3, we will keep it. With filters, whenever you return true for a particular number, then we'll keep that value. And if we return false, it will remove that value. So in our case, any number less than or equal to 3 will be kept. So we will keep 1, 2, and 3, and our new vector will not have 4 or 5. Next, we have the find function. So we can create an iterator, use .find, and again, it takes a closure, and it will find the element where the value here returns true. So if we take num equals 3, what'll happen is the iterator will check 1, that's not equal to 3, 2, not equal to 3, 3 is equal to 3, so the 3 will be returned into find me. Find will immediately return as soon as it finds one, and it also returns an optional value, because there is the possibility of this number not being in this vector. So if we tried to find 40, for example, we would get back none as our return value, since 40 is not present in this vector. Next, we have the count function. This one's quite simple. We have an iterator we call .count, and it's going to return the number of elements within the iterator. In our case, we'll get back 5, since there are 5 elements in this vector. Other useful ones, we have last. Last is another function we can use on iterators. It returns the last element in an iterator. In our case, the last would be 5. Similarly to the find function, it also returns an option. The reason last returns an option is because it is possible to create an empty vector. So if we deleted all the items within the vector and then tried to get the last one, there's nothing here to return, so that's why this one returns an option. When working with numbers, we also have the min and max functions. The min function will return the minimum element within the vector. Since we're working with numbers, it's simply going to return the smallest number. It'll return 1 in this case. We also have the max function, which, similar to min, will just return the largest number. Since our vector is filled with numbers, it will return 5, since that's the maximum number. And finally, another frequently used function is the take function. The take function does what it sounds like. It takes some items from the vector, and then that's the only ones you'll have. So in this case, if we take 3 items, we take the first, the second, and the third. The rest of these will just not be returned. So in this example here, we're creating a vector of I32s. We're iterating through this numbers vector, which has 5 elements. We then only take the first 3, and then we collect into a new vector. The new vector will simply be this vector without these items at the end. So we'll only have 1, 2, and 3 in this particular vector. There are many more functions available on the iterator. Be sure to check out the Rust documentation when you're working with iterators, because it's a tremendous resource when you need to perform functions on your existing iterators. There's other cool things such as putting iterators together, reversing through the iterators, and making them go on infinitely. The key takeaways with iterators is that they do not actually execute anything, it's just a configuration step. So again, with this one, iterator just tells the compiler, hey, we want to go through each element at some point, and when we do, we want to take the first 3. And so at this point, the configuration is done. When we call collect, now collect will say, okay, let me check this configuration here. Oh, I see you want to take the first 3 elements out of this iterator. I'll go ahead and do that, and then create a new vector for you. One last thing to go over is you can chain these functions together. So if we go back up here to the top, we can map each number with the +1. Then we can filter as well. So we can filter each number. So any number that is less than 1 will be returned. In this case, we just added 1 to every single number, and the smallest number is 1, so this will always return false for each element, and we'll end up with an empty vector. When you're chaining functions in this way, they get executed in the order they appear in your code. So first, we're creating an iterator, then we're going to map each element, and then we're going to filter each element. Finally, at the end, we're going to collect all the data into a new vector. You can use as many of these as you like and chain them as long as you want in order to get the desired result. This concludes the demo on iterators. I'll see you in the next presentation.